So let us now treat the circuit analysis in details now. How are we going to determine the current, the voltage, and the power in a DC circuit? By applying a circuit law called Kirchhoff's rule. Let us look at it now. Oh, no. Double H. Sorry. I would like to change the marker. So, the Kirchhoff's law or rules or principle of circuit analysis. See, there are two fundamental principles or law of the Kirchhoff's that describe the behavior of electric current in a what? In a circuit. Yes, uh, they describe the what? The behavior of electric current in a what? In a circuit. They are two basic two basic principle, two basic what? Principle, what? Principles that describe the behavior, describe the what? Behavior of electric current in a circuit. So the Kirchhoff's law propounds two basic laws which describe the behavior of electric current in a what? In a circuit. What are the law? The first law is known as what? Kirchhoff. Kirchhoff first law, and the second one is called Kirchhoff's second law. So I would not like to treat them one after the what? The other, because majority of the students find this difficult. And to be sincere, the simplest aspect of current electricity is Kirchhoff's. Wait, let's go. You see it now. Let me treat them one after the other. What's the first one? Kirchhoff's first what? First law. Kirchhoff's first law. Mm-hmm. Mm-hmm. This is also known as what? A junction's law. And this first law states that the sum of the currents in a circuit that entering a junction is equal to the sum of the current that leaving the junction. The current that is moved into the junction is equal to the what? The current that move out of the junction. That is what? The Kirchhoff's first what? First law. Look at it now. This is said that at any junction in a circuit, hmm, state that state that at any junction, at any what? At any junction in a circuit, the total what? Current I. The total what? Current I. Mm, the total current entering the junction will be equal to the total current leaving the junction. The total current entering the junction equal to total current leaving the junction. Hello? The Kirchhoff's first law. It states that what? The total current that entering a junction is equal to the what? Total current that leaving the what? Leaving the junction. Mm-hmm. Let me explain it in this form, in sketch diagram. So look at it now. If we have it in this form, this is the direction of the current. If a current is flowing like this is I, which is what? The main current that is flowing along this. Look at this dot is a junction. At this junction, this current now splits into two. The one moves like this. The other one is what? Is going like this. So this current, when it gets to this junction here, this is the junction. When the current gets into the what? To this junction, this is the junction. The current splits into what? Into two. What and what? We have what? Let me use blue marker for the current itself. The current splits into what? This is the current. So now split to I1, and here we have what? I what? I2. Or let me call this one what? I1. This one I what? I2. This is what? I3. You can see it from the sketch. The current that is coming from this side, getting to the junction, split into the what? 2 and 3. That is what the what first law is telling us. The total current move into the junction equal to the sum of the current leaving the what? The junction. So from this expression, you can have from this, you can say what? Mathematically, I1 will be equal to what? I2 plus what? I3. Because is the I1 that split to I2 and I3. The sum of the current entering a junction equal to the what? The sum of the current leaving the what? The junction. Are we? Yes. We can now observe that what? Since there is no current staying at this junction, we don't have any current in this junction. No. There is no current staying at what? At this junction. Have you now? We can now say that what? Since, let me write it now. Since there is no current at the junction, since there is no current at where? At junction. Since there is no current at what? At junction. So this tells you that what? You can now say that what? From this expression, if I take I2 inside here, I3 inside, they will become minus. Abi? So we can now restate the law that you cannot restate the first law, cannot restate the first law as this first law. This is the first statement. Current entering the junction, go to the what? Current leaving the junction. So there is no current in the junction. You can now restate the law as what? This first law can also state that what? State that algebraic sum of current at a junction is zero. Please, in a multiple choice question, they will give you that which of the following statement is correct for the Kirchhoff's first law. It says that what? The first one said that sum of the current going to the junction equal to the sum of the current leaving the junction. Right? We can also say that is what? There is no current. This junction here, no current stay there. Current will go and split. So since there is no current stay here, current what? The algebraic sum of currents at a junction in a circuit is what? Zero. So by doing that, we can have what? From this expression here, we can say that what? This I1 minus I what? I2 minus I what? I3 equal to zero. So this is the equation what? 1. This is what? Equation what? Equation 2. This is equation what? Equation 2 for the current. So this expression is the Kirchhoff's first law. This also was Kirchhoff's first law. At every junction of the circuit, no current stay there. The algebraic sum of the current there is equal to the what? Zero. So we can now change this expression to be like this. That is, sum of current is equal to the what? Zero. At what? At a junction. Am I communicating? Good. And there are some basic facts behind the what? This Kirchhoff's first rule. What are the facts? Number 1, this Kirchhoff's rule, first rule, we can also call it, we can also call it what? A junction law. You can also call it what? The first law. This first law. You can also call it what? The first law. You can see that this first law deals with currents. Abi? We can call it what? Kirchhoff. Okay, what? Kirchhoff current law or Kirchhoff law of current. Kirchhoff current what? Current law, which is what? KCL or KLC, anyone you like. This first law, you can also call it what? Kirchhoff current law or Kirchhoff law of current. So anyhow, this first law, we can also call it what? Junction law. Junction what? Junction law of current. Junction law of what? Of current. And again, this law is also undergo the principle of conservation law of what? Of charge. We say that is what? Charge can neither be created, not destroyed, but can be changed from one form to another. This current I change to what? I2 and what? And I3. Have you now? So we can also call it what? Law of what? Law of conservation of charge. Please, in case in the multiple choice questions, so these are the what? All the necessary stuff they can ask you on a Kirchhoff's first what? First law. Some of the current that entering a what? A junction, called the what? Come of the current that leaving the junction. The algebraic sum of the current at this junction equal to the what? Zero. It's also called what? Kirchhoff's law of current. And it's also called what? Junction law of current. And it's also undergo law of conservation of what? Of charge. We say that is what? Charge can either be created, not destroyed, but can be transferred from one form to another. Then let's solve two or more questions on first law. Take example 1. Example 1. Okay. Determine the current I2. Determine the current what? I2 from the sketch above. So we are given this sketch. You have to determine the current what? I2 from this diagram. So let's solve it together now by applying the what? The rules. So solution. Look at the question. This is the sketch. Simple. The 8 ampere current is going to this junction. 5 is leaving, and is what? 2 is what? Is also leaving. So we can say that what? Apply the what? The Kirchhoff's first rule. Some of the current that is going to the what? To the junction. Some of the current that is leaving the junction. Which current is going to the junction here? Is 8. Abi? Can I say what? Using Kirchhoff's what? First law. Using Kirchhoff's first law, we say that what? I1 equal to the what? I2 plus I what? I3. What is I1? We have 8. So we have 8 what? Ampere equal to the what? I2. This I2 plus what? I3 is 5 ampere. Collect the like types. What are we going to have? We have 8 ampere minus 5 ampere equal to the what? I2. Subtract it, we have 3 ampere equal to the what? I2. Therefore, the I2 will be equal to the what? 3 ampere. Take another question. Number 2, calculate the I3 in the sketch below. And this side, let me assume that this is a junction. Let me put what? 12 ampere here. Let me call this place what? 6 ampere. I'm now call this place what? I3. Please look at this kind of question. You are asked to find the I3. The stuff is very easy. Follow the what? This rule. Any current, the sum of the current that's moving to the junction must equal to the sum of the current that is what? Leaving the junction. Please, in this sketch, how many, this is the junction, Abi? Yeah. How many currents come to the junction? Oh yeah? Solution. How many currents going to the junction here? See, 12 is going to the junction, 6 is going to the junction, Abi. So we can call this 12 what? I1, this 6, I what? I2. So the sum of current that's going to the junction equal to the sum that is leaving the junction. So this 6 and this 12 and 6 going to the junction here. This is the junction J. Abi, go to the junction what? J. So you can now say what? This I1 plus this I what? I2. Abi, the two are going to the junction now, right? Equal to the what? This one is leaving the junction. I what? I3. Don't forget, it's not must that you have it in this form. It depends on how they teased the question. The current here is going to this, 12 going to this place, going to this place. From the first law, sum of the current that is going to the junction must equal to the sum that is leaving. So here, these 12 and 6 are going to this junction. This 3 is leaving. Abi. So from this expression now, this is 12. You can now say what? What do we have here? We can agree that we have what? Now, what do we have now? By substituting for each, I1 is 12. You can have 12 what? Ampere plus 6 ampere equal to the what? I what? I3. And we add this together, we have what? 18 ampere equal to the what? I3. Therefore, the I3 equal to the what? 18 ampere. Are we? Let me give you one more before we move to the second Kirchhoff's rule. Example 3. Determine the circuits. The circuit with the current. Okay. We have a circuit in this. This one is also coming here, and this is coming like this. So let me call this one what? 20 ampere. And let me call what? This should be 30 ampere. And let me call this one what? I2. And I say what? Calculate the current. I what? I2. You can observe that what? This example 3 also differ from the what? From this and this. In this sketch, now, before you can solve it, the same procedure from the first law. Sum of the current that is entering a junction is equal to the sum of the current that's leaving a junction. That is the rule. So we have how many currents here? 3. Let's call this one what? I1. This one we call it I2. Here we call it I3. From the first law, we're saying that is what? Sum of the current going to a junction must equal to the sum of the current that is leaving the junction. So here, this is the junction J. B is junction. How many currents going to this junction here, please? Check it very well. It's 20 and I2. The only 30 is leaving the junction. Have you now? You cannot say what? From rules. From Kirchhoff's current law. We say that is what? Sum that is going to the junction, which is what? I1 plus what? I2 equal to the what? I3. Hello? Or no? And let me okay. Call the I3. If you like, I can call this place I3. So I3, what is what? I1 now. The I1 is here, which is what? 20. What of I2 is what? Unknown. What of I3? We have what? 30. We are looking for what? I2. Make it out of the formula. We have I2 equal to the what? 30 minus 20. The I2 equal to the what? 30 ampere. And don't forget, if you have, let's check whether we get it by adding I1, I2, and I3 together. It is give us what? 0. According to the first law, I said the algebraic sum of the current at this junction must give us 0. So for this question 1, question 2, and question 3, if you add what? The 3 together is a must. It will give you what? 0. Let's check for this one by using what? This. Oh yeah, let's sum them together. What is what is our I1? 20, Abi. I1 is what? From this expression, note that I1, from here we have I1 plus what? I2 equal to the what? I3. What is I1? I1 is 20. What is I2? I2 I2 is 10. Sorry. 20 minus 30. I2 is what? Is 10. So yeah, help me to add it together, please. 20, I2 is 10. Yeah, what is I3? 30. By connecting the like types, 20 plus 30 give us 30 minus this 30, we have 0. you can see that is what? This alternative form of first law is what? Is valid. So that is all about what? Kirchhoff's first law of current. So the next thing now is what? Let's move to the what? To the voltage Kirchhoff's law.